Hi everyone, welcome to the construct here to the YouTube channel Becoming a ROS Developer. My name is Rodrigo, and today we'll be having a presentation for one of our students that took the course ROS Navigation in 5 days. And so he's going to be showing us what he did with our environment with the Turtlebot. And hi Tomás, how are you? Can you hear
Hi,
me?
how are you? Thank you for
Good.
being here.
So we're excited to see what your project. So as if you want, you can share your screen and we can get going with it.
Right, I'll be sharing my screen right now. Okay, can you see it?
Yes, we can.
Great. So, hi everyone. I'll jump into the real robot just to use the allocated time for showing it. Then I can go over the codes and explain what I actually did.
Sounds
So
good.
in the first place, I'll be running the simulator same time, so we can visualize all the topics that are being published. We can verify here that the robot is connected by using the joystick. So we're gonna launch the RV's environment. All right, there are only warnings. All right, and okay, so this project is about navigation, developing the navigation code in order to allow the robot to build a map and localize itself. Then we are going to run a path planning code in order to plan some paths all in the map. And finally, we're going to develop a ROS program that interact with the whole navigation stack. All right, so in the first place, we have, right, there we are. Okay, since we still don't have a map, the G mapping node, what it does is it stores the map in the map topic. So we first have to build the entire map, and then we have to launch a node that saves it into a file that we can use for the next steps, such as localization, path planning, and stuff. All right, so the G mapping node was initialized using a parameter file that I set up in order to get the most of this interaction with the robot based on the ranges of the LiDAR and general map configurations.
Right. So you're just going around to get your map and then save it so you can use it with your path planning, right?
Yeah, correct. I'm still missing one last part there. Going too fast. All right, so we are almost there. Okay, there it goes. Right, so now we have the map being published in the map topic. So we're going to launch the map saver by typing cd ROS launch my Turtlebot. Let's go to the package. This is the mapping, and the launch file is called map saver.
Yeah.
Showing this, I can show later what it outputs actually. Okay, so we have the map running here. What we have to do next is to localize the robot. We need to localize in order it to know where it is. So we're gonna stop the mapping server. To localize the robot, we developed this package, which includes a launch file for the AMCL node. Running it won't display anything because it just initialized the AMCL file, node, but it also needs to initialize other things that are included here when we launch the path planning. Let's launch my Turtlebot path planning. We want to initialize the move base in order to get all the transformations. Move base launcher. So what it does, it initializes the move base node, which is one of the most important nodes and components in the navigation stack. We can see now that, or we shall be seeing it in a moment. It is loading the parameters. Right.
Okay.
What we can see here is that when we plot the pose array, we see all the estimated poses are like scattered all the way around.
Right. And what does that mean?
That means that yes, correct.
Oh, but I think it thinks it's in another corner.
Yes.
Yeah.
Yes. Okay. Let's try to do something like that.
You're gonna put the post in another place?
Yes. All right. I think this is more likely what it has to.
Yeah, I think so.
So what it's also being shown here is the local and global cost maps, which are shown in violet and blue. The global cost map is an static. It's being built from a static map, which is the one that we preloaded, we built and loaded in the first scan of the robot. Show it. Right, there we go. The move base node initialized these global and local cost maps, and these values are all these topics are, or these nodes actually are configured using .yaml files. We can talk about it later. What I want to show now is that we can move around. Now that we have a good estimation of the robot, we can move around and spot different record different spots. That is what I'm going to do now. So let's say, for example, this first location, which is let's call it the corner, a corner. So we want to record 1 or 2 spots to be used then to send these spot as references, and then the path planning can calculate how to achieve to these references. So in the position that we are now, we're going to launch the ROS launch my Turtlebot spot recorder, which actually what it does is to
it'll record where you are at the moment, right?
Yeah, correct. Spot recorder launch. Here it goes. Okay, that's the node. Missing. missing.
Looks like there's a missing. Maybe you deleted something by accident. What does it say? Maybe missing
a
declaration at the top.
Oh, maybe the Spotify file is missing.
Oh,
okay.
Sorry. Okay. It looks okay. I mean,
spot recorder node 1. Declaration at the top. Seems to be this. Okay, maybe. Right. If this doesn't work, I have a set of spots recorded.
Okay. I think you have to have that line, and you have to have it in the first line, and it has to have a Python 3. Yeah, that one. Yeah, on top. And try Python 3. Yeah. Let's see if this works. That's called the shebang or something for Python.
Oh, nice. All right. There go things. Okay. So what it does is just start a node that's a topic. And here, the process is called the spot recorder node. So what we can do is to ROS. Sorry, it's a service. This list. This is the one. The spot recorder is a service. So what we can do is to
I'm letting you know that we should probably it's going to disconnect in 1 minute. So just so you know, right now, I think it just disconnected because yeah. All right. It's because we started a little bit late. So sorry to everyone watching. I'm sure we will still get this explanation, right? Have you prepared of something like a video or something like that you can show us?
Yeah, I can end up.
Or in the simulation, you know?
In the simulation from this point on.
Right.
We can work on the simulation. I'm sorry, I should have gone faster.
Don't worry about it. These things happen.
Okay, so it's reloading. Just try to go faster. So what we are trying to find is this structure of data that contains information regarding the positions or poses at different positions of the robot. So, for example, if we are in the
this was just this YAM file is generated from the launch file you were just launching, right?
Yes.
Or so you would go to a point and then launch it, and then you go to another point and launch it. Is that how it works?
Yes, correct.
Okay, I understand.
That is how it works. Okay, I think we can. Okay, everything got disconnected.
Yeah, because now you're not on the. So, yeah, you probably need to close the terminals and just open them again. Like the window, yeah.
Right. Okay, let's start RVs. This, I guess we will have to make a quick map again. Shouldn't take that much.
Maybe you have one saved already, no?
Yeah, that can be. Also, I think this is the one. I think I can get it download.
Yeah, you can specify that one.
If this is the one, yeah, it seems. Oh, let's see. No, that's an old.
That's an old map.
That's an old map. Yeah. There's a map from the Real Robot Lab, also.
Oh, I see.
So, okay.
Oh, that was quick.
Try to not be quick, just to have something to show. Right, we have here. Okay. Okay, we move the robot around. So it builds a map. All right. And a bit there. Okay. All right, I think we can work.
Yeah, I think that's good
that.
enough.
And okay. We are saving the map now. And we can right? So we have the map. We are going to end up this slum node and the teleop command. Okay, so let's launch.
So now
talk about
the navigation, right?
Yeah, the move base node. Okay. And the spot recorder, what I was mentioning before, is that it returns something like this. This type of structure, we already have it loaded. We don't wanna. I don't wanna use much of your time, so we're going to use this structure of data. Now that we have the move base node running, we can set. We can verify that the pose array is showing something. If not, we have to move the robot around, just as we did before in order to localize it. So again, we see it's all spread.
Sometimes what I do for this, I'll make a quick script that just makes the thing rotate, right? So
yes.
it did it really quick and it did it fine. Yeah.
Okay. Yes, to automatically rotate and get ready like automatically, right?
So in here, you already have move base, right? you have
Yes,
launched
now
it.
it's moving the move base. Yes.
So technically, you could give it a goal, and it would try to reach it, right?
Yes. 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 We can try that. All right. Our best. That's good. The first thing we can try is to basically we can hide the pose array. If we ask the robot to move here, it generates a plan, and a local and a global map plan, and it tries to match it.
Right, and that's replicating in the simulation, right?
Yes, it's been shown here in the S0 window.
Okay, I see it.
Basically, example of how it reaches final pose.
And how does the system get this goal?
It receives the goal through the. Okay, this is automatically done by this command here, but it can also be done if we send a pose input to the move base / goal topic.
Right. Okay. So it's an action, right? So you're getting feedback from this. If it fails, if it doesn't, right? Okay.
It's the goal of the action. All right. So up to this point, we've got all these different poses at different positions of the robot, and what we have to do is to demonstrate the interaction with the navigation stack. To do so, we are going to launch the navigation. We want to keep that. Let's launch the navigation packet, the navigation launch file, which basically it initializes. It takes one of these data structure, and it sends to the goal of the move base action.
Depending on your input?
Based on a label that is indicated with
right. Okay.
Corner 2. I can show you how it works now. Navigation, launch file. Okay, so it starts the get coordinates service server. What the coordinate service server does is it gets a label and it associates it to the data structure that I showed you before.
Right. So you're going to call that server
spots
with it.
Yes.
With the label. Okay.
Get coordinates.
Here I see.
Service call and get coordinates. Double tap. All right. Here it asks for the label. In this case, we can call the label as pedestrian. Spots here. Pedestrian correspond to the crosswalk.
Yeah.
So if everything goes well, it should be
go
reaching
to
this
the
position.
Oh, okay. So it's going.
So here it's generated the oh, it's a bit far. Okay. That depends on, maybe I put the spot too far from the final position.
What does the output of move base say? So where you have your navigation.
Sorry, can you go what?
So your where your move base is, where your path planning launch was, that would be there would be an output if there's an error. So maybe it didn't reach all the way there. So
yes, that was something that I was struggling with, because even if I can see the status, I mean, the move navigation can return the status or the result. And if it's, for example, number 3, I think that means that the navigation was successful. And after a if sentence, we can stop the program. Still, though, I couldn't find out why, even if it's close enough, it doesn't quite exit. I mean, it doesn't return the successful navigation.
And this happens for all the locations? Because maybe that spot is too close to the cost maps, you know, so it's thinking, oh, I can't go all the way there.
Okay, yes, and this is a problem I was having. The code doesn't, the program doesn't stop because it is still waiting.
Right. So you never get a success.
Yeah, I tried to monitor it different ways. I couldn't get to the solution.
And do you, if you send a normal navigation goal, does it arrive? So if you don't use the service, if you send it like with the Arvis, I think it did, right? Because you just did it.
Yes, I didn't monitor actually the I could do that. I think that if I ROS topic I don't know how to check if the move navigation node, the move base node, it returned a success, I think.
So I can tell you, if you go one of those other 3 terminals, one of them will be move base, your path planning, and there'll be an output there.
Oh, okay. Since
it's this one. No, it's gonna be too hard to find it, because it's so when you get a new plan, it says got new plan, and
this is probably it is trying to reach. No, this is trying to reach the previous.
Yeah, the previous one. So you would have to kill it and launch it again.
Yeah.
Do you mind killing the path planning and then like sending it to another spot that you put from your program?
Sure.
So instead of pedestrian, let's see what happens when you send it to a corner.
Yeah, it launches everything: the localizer, the move base node, and the map server.
Mm-hmm.
And all right, here we are. We just check if the pulse is well. Okay, it's localized. Okay, and the service called get coordinates / double tap table. Let's move to, let's say corner 2.
Mm-hmm. I think I know what the problem is. So, do you see how the beginning of that red arrow, it's already on top of the cost map and obstacle layer detection, and I think maybe that's why. So if you were to send it to a goal that's like in the middle of an open area, but now we're gonna have to, okay, but we would have to relaunch the nav nodes. But yeah, you can see how it's trying to get there, and I have a feeling. So you can cancel this and just in RViz you can send another one, another goal, and try sending it. And if it doesn't, we'll just.
Yeah, no, it's.
Oh, because you're still calling the service. So call it, kill the service.
Oh, I have to build up the navigation.
Oh, that's fine then. Don't worry. That was just an idea I had, but I think is this so that was the end of the project, right? So you send it to certain locations, and we saw that it did that. So is there anything else you want to show us for your project?
No. I mean, I went over all the steps in this project. I'm sorry I couldn't make it all in the real robot lab.
Oh, don't worry, it was a lot of things. So if you don't mind, you can stop sharing your screen.
Sure.
So
okay.
All right. So I think. All right, let's give me a second. Okay, we're good. So, congratulations, Tomás. This is actually our first navigation project that is presented. So there were bound to be issues. We also had some connection issues with the internet. So when you see the video, you'll see some cuts. I don't know what was happening. I apologize about that. And
okay, no problem.
But I really liked I mean, it was really well structured, and you did all of the sections. That's what I was. About the navigation never reaching the goal. That's always a parameter issue. So it's either the fact that I was saying that it was too close to an obstacle, so I was always trying to arrive there. So that's what I was telling you. You know, try and send it to an open area and see if it reaches it. And if not, then we could go and see other parameters. But I mean, the main things, which is set up the navigation stack and create a node that records your position, so you can call the service. I thought that was really good. You implemented the service server. Congratulations again, and
no.
I think I think you did well, and I think even though there were errors, you showed that you knew what you were talking about. So I appreciate this, and congratulations again.
Okay, thank you so much.
All right, so for everyone else, this is, you can do this, and we'll keep trying with these things and till we get it right. And this is the best way to do it, is show it in your show your skills in this presentation. So everyone else that wants to do it, come right ahead and we'll do this. So thank you, Tomás, very, very much, and we'll see you next time.
All right, thank you.
Okay, bye.
Have a good day.
Bye, everyone. Listo.
Okay.